2017 higher level question 1, orthographic projection. Question is: pictorial view of a road roller is shown, also shown as a 3D graphic of the roller. Draw an elevation in the direction of arrow A, project a plan from the elevation, project an end view in the direction of arrow B, and final part of this question, determine the true shape of the surface S. This question follows the same format as all the other ones. You've got a cylinder that's cut by a flat surface, so you must find what that cylinder is going to look like, and you got a true shape also to work out. So, looking at our question, I'm going to set this up. With all my questions, I put them into a box first to make sure that everything fits on the page. Arrow B is at the left hand side of arrow A, which means the end view is going to go on the right hand side of it. So our elevation is going to go here, plan below it, and end view off to the right. The total height of this question, if we work that out, so if you look at the back, you've got 28 radius, 28 times 2, 56, plus the 18 plus 54 is 102, so it's 102 tall, so we just need to make sure that we have at least that much space above it. There's my XY line, my ground line, and the length of the elevation we're given is 166, so it's 166 from left to right. Putting 20 between it, making sure that it fits on the page. And then the width of, looking in the direction of arrow B, the width of it there, it's not 72, that's 72, and you could get confused by it as well because the 14, 44 and 14 up on top of the cab are also 72, but you need to add the thickness of the wheels on, which is 15, but remember they're on two sides, so it's an extra 30, so that's going to be 128, 102 wide. So we got this much space here. The height of it is 128, so 54, 18 and 56. 128, so mark up the height of that. So I can create a rectangle that both of these views, or two rectangles that both these views fit into. So then when I'm drawing, no, I haven't forgotten any shape, and also it'll all fit on the page, and I'm not going to get caught by that. So let's say I get the elevation drawn, and then I come to realize that at the end of it, or just I'm about to start the plan, it doesn't fit on the page. So we're going to start with the elevation, just finding some of the key pieces, the cylinders at the front. I'm going to break it down into its kind of individual parts. So there's a 42 first. So half that 21 is going to be where the center of the cylinder is. And up here 21. So that's the center of the cylinder. Doing the one at the back, done the same way, so it's radius 28, so in 28, and up here 28 at the back. So center for the back wheel, center for the front roller. So I'm going to just draw them in now, just to give us kind of a reference as to what's going on. One and the second one. One and two there. So next what we're going to look at is putting the general shape of the body on it. So the top across here, there's going to be part, so there's a horizontal piece sitting up there on top of the front roller. That comes back a distance of 42. giving us a point there where it's going to start sloping down along this way. Now we need to find where that's going to start sloping, so we've come in the distance of the wheel here, and then it's a further 23 in to that point in there. So in line with that is where that's going to slope down to, but just be careful, watch at the bottom there is a 10mm gap clearance between the bottom of the cab and the ground. So this is the point that we're actually looking for. Why is that so bright? So this point here is the point that we're actually looking for. So we've come back 23, so 42 first, then 23, and up 10 gives us that point down here at the bottom. Now that's going to continue all the way into the back. Hidden detail behind the wheel. And solid again there at the back. So that completes the lower part of that there. Next part to this is to find the positioning for surface S. So surface S is going to have a vertical line coming up along here and another one up a little bit further. So that's one is directly in line with the wheel and the other one is going to be in 25mm from that in here. Now we won't be able to work out the top part of that until we have some more of this drawn. So that's just giving you a general idea of where surface S is going to go. Next we'll have a look at drawing the cab and the front of the cylinder here. So we'll put on our sloping surface onto the front of that. So it's up a height of 10 first, and then up a further height of 22 from there, which is going to give us the top of that cylinder. So this point would be the center of the cylinder, so it comes up 10 first, that would be the center of the cylinder running along this. This is the top of it, the top edge. And from the front edge we come back 35, and that gives us the slope on this piece here. And this horizontal line here is going to come all the way back until it touches the line off the front of surface S. So this piece here is coming straight up and then it's going to curve around the top. Now what this point also gives us is the front for the sloping edge of our cab. Now we're not given a distance up here up on top for the length of that cab. We need to work it out, and to work it out we need our compass. So we're told that it has a sloping distance of 65, so I'm going to set my compass to 65. So from this point to this point here is 65. It's going to measure that. Front edge here at this point until it cuts off the top. So this is the top of the cab until it cuts off that point, and that will give us the sloping edge at the front of the cab. So just going back on that, we're told that the sloping edge of the front of the cab is a distance of 65. We're not given a distance from here to here, so if we measure 65 from this point with our compass, swing an arc, it's going to cut through that top point up there and tell us where that's going to be. Now, so we have a few more bits that we need to work out. First, there's a line running along here. The height that that's at, that height is at the same height as this point is here. So from this point across to here, start to surface S, we have a line there. Now, we can't find this point just yet. We need to do that inside in the plan, or a combination of the plan and the in view. So here's surface S, and that is pretty much all of the elevation complete. Just need to do a bit in the end view first to get this point up here. So next bit that we're going to have a look at is the plan. So drawing our plan, we're going to find the center line for this, which will be 51. So this is going to split that in half, half and half. And from here, we're going to work out the distances that pieces are on either side. So if we start with the cab, or the cab bit up here, that comes out a total with either side of 44 for the very top of it. So total 44, so 22 on either side. The distance forward that is can be brought straight down from the elevation. So this line here forms the very top of the cab. Now what I'm going to mark on next is the distance out to the full width of the body, because the wheels are extra onto the side of that. So it's 14 millimeters on either side, as given in the question. And the widest part of it is the piece that's around the wheel here. So it's going to come narrower up on that part. So this is as wide as it gets, down to this point. So we can mark on the wheel because they're also in line with that there. So now what we're going to look at next is, so we've got the top of the cab. Now we need to find the cylindrical part here at the front, what that's going to look like. And that has a radius of 22. Now it says R in the question, but if we're told over to the left hand side of the dimensions that it's up a height of 22, that has to be the radius, because it's from the center up to the top is radius 22. So again, we've got 22, we've already that marked down here. It's the width of the top of the cab, so we can use that distance there also. So coming back in along this way, here and here is the full width of that, and it's that wide until it touches off here. So this is again the front of surface S is where it's narrowest, the 44 wide, so we can bring that distance down along here, and it's narrow running along this part. Now to find the slope coming down along here, so this is an edge view of surface S, so I can draw that one in. So down here in plan, this here is surface S, an edge view of it. It joins from this corner to the one just next to the wheel, and the equivalent surface on the back of it gives me that there. We have two lines that are going to come down along here, which would be these ones. And we need to find where they are. So they are joined, if we see in the question, if we look just above the vertical line coming out of surface S, that joins diagonally from that point up to the top, the front corner of the top of the cab. So we can have a look at that. So we're going from this corner here down to this one. So from here down to there, that's going to give me that line here, and same on the opposite side. So from here down to there, and that's just showing where that's coming from. Now what this also gives us is this point here. this point is the point that we're looking for up here. That will help us with the surface S find the actual what that appears as up here. So that completes the elevation, and we have a good portion of the plan done now. So the few bits now that need to be left, that are left to do, is the front roller, which as a cylinder and the way we're going to be looking at it, it's going to appear as a rectangle. And the width of that is the same as the body, so back here, so I can take this distance, project that forward. And it continues underneath it, which means there's hidden detail underneath it. And solid line across the front. Now we can put in a center line. Just to show that it's a cylinder. And there's the back also. Now this almost is complete. Aside from the curve, which we'll do at the end, or second last, the only other piece is indicating where there's a change in direction. And if we look at the elevation, it's flat the whole way along. Then there's a change, there's a corner here, change in direction, so it's going to come up along this way. Then it changes direction again, going like that. So here, there's going to be hidden detail, and here there's also hidden detail. Now this one is already covered because we got hidden detail for the edge of the roller. This one we must put in, so it's a change in direction. So at this point here, it needs hidden detail running across the width. And that is the plan, except for the bit of the curve here at the front, so at the cut surfaces. Next part to this, I'm going to draw the end view. So the end view is looking in this direction. We've already positioned our rectangle here on the right hand side where my view is going to go. And I'm going to start by drawing the rollers again. So roller here at the front. It's that height, and we can take the width of it, so it's this width, project it back. So this gives me the roller at the front. Again, it appears as a rectangle. And just putting in our center lines to show that it's a cylinder. Now on top of that, we've got the cut cylinder. So we're going to bring up the height for that now next. So that comes up to this height, so it's up 10 millimeters first, and then it comes up a height of 22 on top of that. So taking our central axis, that's going to give me positioning for that, and the full width also. Now, as we're looking in this way at the cylinder, even though it's cut, it's still going to appear as a semicircle. So, circle there on the front, and then our two vertical lines coming down for this little block here. So that's the very front of it. Now what we're going to do is we're going to start working our way back. So the next bit that we can see is this face here, and we can see in the question that that is a cylinder going into the just next to the front of the cab. At the bottom of that slope, it's kind of square. So that's going to give me square edges here. Next we're going to draw the cab, so the top of the cab is at the same width as this, so that comes up to the very top points. That's the very top of the cab at that position there. And let's find the sloping lines coming down along this way now. So they're based on this sloping line coming down along here and here. So if we can locate these corners and then join those two lines down, it'll give us those positions. So they are going to be this width, and we're going to join them from up here down to here, but let's do it lightly first, as there's still a few bits that we need to put on it. Now we can darken these ones in. Right. And again, vertical lines coming down for the body. Final piece now, the front window slopes back this way and this way, just like we figured out down here and here. So we can take the height that these are at and project them across, giving me this point up to here and this one going this way. This surface in here now is surface S, but there's still a little bit more that we need to do with that. So we have the cab, we have the piece here at the front, the engine part of it. We've got the front roller. We need to put the roller now onto either side of it, the back rollers. The height of them is brought across, and we already have their width, their positioning here. So I can darken in those bits. Now the only bits that are left are in relation to the hidden detail. So as we're looking in this way at it, we can't see the clearance underneath it, but we do need to recognize that it's there. So that is at this height, so I can project this height across. Now it's not out in the rollers at the side, but it is in the body at the middle. So we have hidden detail running across here. And then there's also hidden detail for surface S. So these lines here continue down behind the roller, so they continue straight down here behind the roller, so they also need to be recognized. So continuing these lines down along here gives us hidden detail for where surface S should be. And that completes the, almost completes, forgot one line. This line running across here, which is that line there at the front. So that completes the end view. Two more parts now that need to be done in this question. We need to put a curve onto the front of this here, and then we need to find the true shape of surface S. We can do it in either view. So what I'm going to do now is I'm going to find the curve here at the front of this, and to do that I need to divide. We're always given it as, so it appears as a semicircle in one view, we see it as a straight edge in the second view, and then in the third view we're going to see it as an ellipse. So what I'm going to do is I'm going to divide this semicircle up with my 60-30 degree set square. You don't have to use these measurements, but it's quicker and easier if you do. And label each of the points. So over here we've divided up or just found points on the curve, so that in the same way that we had a number of different points over here, curves don't have corners, so we need to pick points on them so that we can draw our best curve that we can, our best free fit curve. What we're going to do now is we're going to find each of these 7 points on the sloping surface off over here. So they're going to remain at the same height, so they can just be projected across. So this is 7 and 1, The next point here is 6 and 2, 5 and 3, and point 4 is up on top. Now it's just a matter of combining the two views. So if you have something in two views, you can find it in the third one. So this is point 1, point 7, and point 4 can be brought down from up here. It's on the center, so that's our point 4 there. So I'm going to take point 2 first, and I need to get point 2 down into the plan. So onto the XY line, 45-degree angle, and point 2 is somewhere along this line down here. Where it is going to be directly below where it is in the elevation. It's going to be the same distance back in, so this is our point 2. Going to do the same thing for point 3. So point 3 projected into the plan from our in view, and can bring point 3. I'm extending that line on a little bit further because it'll also give me the line for point 5. So I already have point 4, point 5 next. Point 5, and finally point 6. And let's continue on down. Give me point 6 there. Joining these up the best that I can. Gives me the curve at the front that I'm looking for. So just recapping on that, and I'll color in one of them so we can follow the lines. So point 3 is brought from the elevation and the end view down into our plan, and where the two lines, where the points intersect each other, gives me point 3 down here. So that completes the part A, B, and C of this question. The final part of this is to determine the true shape of surface S. So we just need a true shape. So there's two ways that we can do it. We can project an auxiliary view coming down off of this, or going up that way. There isn't much space on this one, so it's probably not best to do it here. The alternative is to rotate it around so that we have a view of it, a better view of it. So what we can do is we can swing it from here around until it's horizontal, and then draw it up here in the elevation, or you can do the same thing, rotate it around further. So rotate it around this point, or around here until it becomes horizontal, and then you'll be looking in perpendicular to it in this view. So we can either rotate it so that it's perpendicular to us in this view, or in this view. I'm going to do it in the elevation. So all I'm going to do is, with the compass, I'm going to keep this point here fixed. This is my axis, which is this line up here. I'm going to rotate that around the rest of the surface, around the other points around until they're horizontal. This is a horizontal line, that's 1. And 2, so rotating them around until they're horizontal. Projecting each point up along here. So this point now is this one, so this gets wider to off over there. Same for the one up higher. So this is the point on it. This point is taken, and that comes across horizontally to there. So that surface now completed looks like. So this line is going to stay fixed. 1 up to this point, out to here, and back down. So the green here is the true shape of surface S. And that completes the 2017 higher level question 1.